Copper is one of the most widely used and important metals for our lives. It's extremely easily shaped, but still quite hard, which means it can be used to make things like water pipes. It doesn't react with the water, it's non-reactive metal, and it also conducts electricity really well, so is widely used as electrical cabling. There are two main ways that we extract copper. The first is from what we call high-grade ores, which are ores with a high concentration of copper inside them. And when we get an ore, something like copper carbonate, or there's lots of different ores, the first thing we have to do is something called smelting. And smelting basically involves heating up the ore and reducing the ore, removing the oxygen using either oxygen or using carbon. So we need about roughly 200 degrees C for smelting. Once we've done that, we form what we call crude copper, which is an impure form of copper, and we then have to purify it. And there are different ways to do this, but one that is commonly used is electrolysis, whereby we make our impure copper the positive electrode. Impure copper. And we have a solution containing copper ions. And what happens here is our positive copper ions will move to the negative electrode when I put a direct current through the system, and I get pure copper forming at my negative electrode. I can then collect that copper, which will then be pure. So clearly both of these steps are going to be, again, quite expensive. However, I can get copper quite easily by using these. One issue with this is that both mining the copper, is going to damage the environment. We have big holes in the ground. It's going to cause environmental damage and use quite a lot of energy. In addition, these high-grade ores are a limited resource. They are running out. Which is not ideal because we still use copper extremely widely. So over the last few years, chemists have been trying to develop ways of extracting copper from low-grade ores, which are ores which contain a lesser concentration of copper. Now, normally we wouldn't think about using these low-grade ores to produce copper, simply because there isn't enough copper in there to make it worthwhile. However, chemists are now using biological methods to try and extract and purify copper. The first method we need to know about is something called phytomining. And this involves basically using plants to purify our copper compounds for us. So what will happen is I will have some form of plant. Okay, and the roots of the plant will absorb some of these copper ions, copper compounds from the soil. And what then happens is my plant will concentrate or increase the concentration of copper ions inside it. So I've gone from having quite a low concentration of copper ions in the soil in the form of copper compounds, and they're then purified inside my plant. What I can then do is burn my plant. Okay, so I've burnt the plant, and the ash that's left over will contain a high concentration of copper ions. So I can then collect these. Normally I actually use sulfuric acid to form a copper sulfate solution, and again I can then use electrolysis to produce pure copper. So this is one way of using plants to purify, to increase the concentration of copper ions. The second method that I can use is called bioleaching. Which is fairly similar, but this time we actually use bacteria instead of plants. So here we have bacteria in soil. And again, these are going to absorb some of the copper ions which are in low concentration in the soil. And they actually end up producing something called a leachate, which is a solution containing a much higher concentration of copper ions than was originally in the soil. And again, once I've got this slightly higher concentration of copper ions, I can extract them and form pure copper using electrolysis. In addition to purifying our copper compounds using electrolysis, we can also use scrap iron. And since iron is more reactive than copper, the iron will displace the copper from its compound. Just an example, let's say we have copper sulfate. If I were to react that with scrap iron, okay, iron will remove the, or displace, sorry, the sulfate from the copper sulfate. I'll be left with pure copper. And iron sulfate. So this would be used somewhere where I have lots of scrap iron that I want to kind of get rid of or use up. And I can do that instead of using all that electricity to do electrolysis.